Chapter 8, Section 2, Translations on the Coordinate Plane. We have concluded the Pythagorean theorem portion of the Chapter 8 boot camp. Now we're going to focus on the transformation portion of the Chapter 8 boot camp. And the first lesson in that section is translations on the coordinate plane. I purposely started with this lesson because I feel it's the easiest of the four. We're going to be talking translations, rotations, reflections, and dilations, but I think this one's the easiest, so I wanted to start there. We have two goals for today: to transform figures by using translations, and then to transform figures on a coordinate plane by using translations. Now you can kind of see from the picture that a translation is simply a slide. You are just moving your object or your point from one space to the next. You're not changing the size, you're not changing the orientation, you're just moving the location. The first goal we have for today is to transform figures by using translations. So if I'm just given those points, how can I find my new values? The second one is to transform figures on a coordinate plane. So if I'm given a figure, a picture of a figure, how can I transform that? How can I translate that shape? There are 3 vocabulary words that you could consider in this lesson. Remember that you get to pick which vocabulary words you want to use for the 10, but here are 3 that you could choose from. The first one is transformation, and that is just in general a movement of a geometric figure. And as I said earlier, a pre-image is the position of the figure before the transformation. So when you're given basically the problem, that is called the pre-image. Pre means before, so it's before I do anything to it. And then image is the position of the figure after the transformation. So once I have slid my shape or translated it, what is my final image? All right, so we had 2 goals for today. One was just to translate an image based on the points, and then the other one is to do it on the coordinate plane. So let's take a look at how that happens first, just by using the points. So if I am given an ordered pair and I want to translate both x and y, we typically look at it like this. So I'm going to add a to my x value. That is my right or left shift. And I'm going to add b to the y value. That is my up or down shift. So in this particular case, let's just say I wanted to translate it +2 and +3. Okay, so my x value is going to be going to the right 2 and my y value is going up 3. Okay, I'm going to go to the right 2, 1, 2, which gives me my location here, and then I'm going to go up 3, so I'm going to go 1, 2, 3. Okay, so that's how it's going to look if I have a shape. But my first goal is saying, what do we do if I'm just given the ordered pairs? So all I'm going to do is add 2 to my x value and add 3 to my y value, and I will end up with 4, 0, which, if you will recall, is exactly where my dot landed. Okay, here are the translation rules. To translate a figure to the right a units, I'm going to increase the x coordinate of each point by that amount. So if I'm translating the point P, which is at the ordered pair 3, 2, 9 units to the right, I am simply going to add 9 to 3, and that will give me my new x value, which will then be 12. So my ordered pair would be 12, 2. If I wanted to translate my figure to the left, then I'm decreasing the x coordinate, so I'm simply subtracting 6 units. So in this case, if I'm going 6 units to the left, I'm going to subtract 6 from 3. So we get our subtraction here. So my new x value is -3, and again, the y value is not going to change. Now notice, I don't need a coordinate plane to do that one. I don't have to plot anything. I'm simply using the ordered pair and what I know about my translation to get my new point. Let's try going up and down. If I'm translating my figure up, I'm going to increase the y coordinate by a units. So if I'm going 9 units up, I'm simply going to add 9 to 2 to get 11, because 2 is my y value. So my new y value is 11. My x value stays the same. You're going to notice here that I'm using the original point label, but I'm putting this like apostrophe after it. It's called prime, but it's your secondary point. So your original is going to be like A, B, C, and then your secondary is going to be A with that apostrophe, B with the apostrophe, and C with the apostrophe. Okay, continuing my translation down, Again, that's impacting my y value. So down would be negative or minus. So I'm going to subtract 6 from my y value to get a new y value of negative 4. And I'm keeping the x value exactly the same. So that's what it looks like. If you're not given a coordinate plane or you don't want to have to get graph paper out, that's all you have to do to get your new points. The second goal was, what if we're given a picture and we want to translate? And I'll be honest with you, way easier to do if you're given a coordinate plane, just because I think visually it's easier than mathematically. So for example, if C is my original, and I want to shift it 6 units to the right, I'm just basically taking each point and moving it 6 units to the right. So I take point A and I'm going over 1, 2, 3, 4, 5, 6 and putting my new point there. I'm taking point B and going over 1, 2, 3, 4, 5, 6 and putting my new point. C, 1, 2, 3, 4, 5, 6 and putting my new point. Obviously, you don't have to put those little arcs. You're just counting, okay? So again, if we want to prove it, if the coordinates of point A are negative 5, 4, which you can see, negative 5, 4, and I'm going to the right, I'm just going to add 6 units to my x value. So my ordered pair is going to be 1, 4, and sure enough, there it is. If I am going to the right 6 units with my b value, I'm just adding 6, so I get 4, 3. And same thing with this last point, I'm just adding 6, so I get 3, 1, and sure enough, there it is. Don't have to do it mathematically. I can just do it on my graph way easier. Notice the shape is exactly the same. Notice the orientation is exactly the same. The location is the only thing different. Okay. The homework assignment for this lesson is a worksheet. It's a riddle worksheet. So you're actually answering just a couple of questions here. It is 2 pages long, so just be aware. The riddle is, why was Tweety Bird's wife rushed to the hospital? What you are going to do is solve the problem and then find the answer and find its matching answer in the answer box, and then you're going to use the riddle to decode. So the nice part about this is here are all of your answers on the bottom of the second page. If your answer doesn't show up there, then you screwed up, okay? So if you come up with something and it's not in your answer choices, then you're going to want to go back and try it again. It doesn't tell you how to solve these, so you could get out graph paper and plot them that way, or you could do it mathematically. Either way, it doesn't matter to me. I did do 4 of them for you, but I don't want to go through those on the video. I want to go through those in class. If I were you, I would try them first. All you have to do is move the box, and then you'll know if you're correct or not. Don't just cheat and move the pictures, because that doesn't teach you anything. Try them, and then you can at least check them. Your final G for this lesson is, does translating a shape change its size? That's what you want to know. Write that final G in your notes. Highlight it or circle it somehow so it's easy for me to find. If you have any questions, let me know. Good luck.